Right, okay, I think we're good to go. So just like to say a big hello to everyone and welcome to Fruition's lockdown learning series. I hope everyone is well and keeping safe. Learning in lockdown is a way for Fruition to keep the tech community engaged and ensuring that we can give something back during these very difficult times. I'm Rob Foley from Fruition, and today we're very proud to present Airelogic's COVID-19 symptom checker webinar, which is quite a mouthful. I have practiced that. Fruition are a Yorkshire-based IT recruitment company. We're very much still open and recruiting, so if you want a chat about the market or any of our open roles, then please do let me know. Airelogic are a leading health tech business based in Leeds. They work on many worthy projects and have produced a new application to check symptoms for COVID-19. They've used some really cool technology, and I believe they've been featured on Look North recently as well. Airelogic are very much one of the favourite companies that we work with. It's a company that sells itself. The projects that they typically get involved in have a direct impact on patients' well-being while supporting clinicians throughout the UK. So without further ado, I'd like to introduce Airelogic. So we've got David, Julie and Daniel. If you'd like to give an awkward wave, there we go. Julie is one of the senior business analysts, and she's going to talk about the background to the checker. David and Daniel are going to talk through the technology and how the application has been created. SuperRAD low code is a new concept, so for me, I'm really excited to learn more about that, as well as machine learning, which I still find quite mystical in terms of what that is. So without further ado, I'll hand over to Julie and David.
Great, okay, so I'm going to share my screen. Hopefully we can all see our slideshow.
Yeah, so that's quite a mouthful, isn't it? So fight COVID-19 together using SuperRAD, low-code tooling and machine learning. And that's the website for the COVID-19 symptoms tracker. And you can also be redirected by typing in fightcovid19together.co.uk. Okay, should we move on? Okay, so I thought, as we're all here, we all know the timelines that are on the screen at the moment. So we've all been part of this together, and I guess what I wanted to do was to kind of include this just to show you the speed at which the virus has spread, and on the back of that, it kind of mirrors the speed at which we've had to react and find an initial idea and then build obviously the tool that we've got. So middle of March, when the pandemic was recognised, I think that's when we formed a group at Airelogic, and the development team was formed from developers that we've got. We've got data scientists at Airelogic. We've got UX designer was also involved, myself, business analyst, tester, and also critically was our legal team as well, because obviously we knew that we were going to be putting together a tool that potentially will be used by the general public, and we knew that we would have to be making decisions very quickly. So from the middle of March to its launch, which was, as Rob mentioned, on Look North, which was the middle of April. So all in all, it was about 4 weeks. And of course, here we are still in lockdown, still potentially utilising the tool and looking at other use cases that can come out from the tool. So if we move on to the next slide. So just a little bit of background, really. It wasn't just us at Airelogic. We have a really good business partnership with hospitals in Manchester and also across the Yorkshire region, particularly at Leeds hospitals. Airelogic developed and implemented their secondary care system there, so the electronic patients' records. And I guess one of the USPs that we've got is that we wanted to have a tool which could potentially link in with the medical records, not just at Leeds, but also any hospital. We linked in as well with the Bradford Institute for Health Research, so we knew that potentially there would be data that could be used in the future by data scientists and researchers. We also knew that this was the first tool that we would use to the general public, and we have no social media experience as such, so we reached out to Zeal, who kindly offered their services, and as did 26 Digital. Again, there's no commercial arrangements here, everybody's just doing their bit for COVID. So yeah, so obviously the Airelogic team with our own legal team as well worked collaboratively in partnership. Again, so we had the initial concept. We worked closely with medical clinicians and understood what the requirements was. It's very simple form, so nothing complex as such on a level. But we managed to get a minimum viable product up and running in 2 weeks. Once we had the viable product up and running, we needed to make sure that it was fit for purpose, it was scalable. We weren't quite sure what the uptake would be, so we carried out lots of functional testing, non-functional testing. Another USP with the tool is that we wanted to have full accessibility with it. During this time, we knew that there were other apps out there, and we were by no means in competition with the other apps. Indeed, behind the scenes, we reached out to St. Thomas's group, who had the Zoe COVID app, and they're a subset of them that were based in Swansea, and we're still in discussions with them. But we knew that we wanted to have full accessibility, so our form's very, very simple. It adheres to Web Content Guidelines. Then we had a further preparation of getting ready within that 2 weeks, getting all the external stakeholders together and getting us ready for the launch, which was on BBC Look North and also Radio Leeds, and again through the social media channels, LinkedIn, Facebook, and so on. And also we can potentially, we're targeting specific target groups, such as it's going to be used by Manchester, NHS staff at Manchester. Sorry, I've gone on and on. David, I'll hand over to you now.
Okay, great. So yeah, my name's David Bond. I'm Chief Developer for Airelogic. So I'm going to be talking a little bit through the tech side of things, how we managed to throw this together in less than 2 weeks, and how we managed to plug together various different components to make this all work. So one thing that unites Airelogic's products is we tend to build lots of low-code tools, and of course we're a health tech company, so everything we build is geared up for being used within healthcare. So to kind of put it in perspective, the name of the talk involved SuperRAD and low code and machine learning, all these kinds of words, buzzwords, if you will. SuperRAD, I think what it means to us at least is, RAD is rapid application development. So we stick super on the front, and it kind of implies that you can iterate and produce software very, very quickly without having to think about code deployments and think about maintaining servers and infrastructure and all these kinds of things. So examples of what we would be considered to be super rad and low code tooling that's a little bit more mainstream might be something like Wix, for example, for building quick ad hoc websites, or something like Google Forms, which is closer to one of our products, but again, more kind of commercial and mainstream. So to kind of place the technical landscape together here, two of these icons on the chart here are our products. So of course, Forms for Health is our flagship product, and AirGlue, which is our integration engine. And the rest of them are probably tools that people are familiar with. So Elastic is a NoSQL database with a search engine built on top and a whole bunch of other functionality. Kibana is typically speaking used as a UI front end for Elastic, and it has a whole load of machine learning and dashboard charting functionality available out of the box. And Redis is a again, a key value pair, NoSQL kind of state management tool, which we use to contain some state for this overall thing. So before I jump into, because most of what I'm going to do is just demoing the tools and how they come together. But before I do that, I'll just talk us through a kind of high level architecture of what we produced here. So over on the far left hand side, we have a citizen, and that is someone who is providing their symptom reading. And I don't know if we mentioned kind of what the overall flow is, in case people haven't actually used our tool. It's a form that you complete once daily, and it asks you what your symptoms are, and it asks you generally how you feel. And the idea is that everyone completes it once a day, whether they're well or unwell. And it means that we can gather all this data about how the epidemic is spreading, and also, more importantly and more interestingly, what symptoms people are showing under different conditions. So the citizen would interact with some kind of device. As we can see on the diagram here, they're using an iPad, but it can be anything. Our system is web enabled. It runs in a web browser. And then under the hood, we run a proxy, and that will serve either our marketing website or our front-end website, or the form itself, which is served from our product, Forms for Health. So Forms for Health is the kind of UI layer, the presentation tier in this equation, and it then sends the data in XML to our integration engine, Aireglue. And Aireglue does a few different things. One of the things it does is we are given a postcode by the user, and we need a latitude and a longitude for that postcode. So we make a call out to a free and public service called postcodes.io to get a latitude and a longitude and a few other bits of information about that postcode. From that point, we then need to put the data, first of all, into our Elastic Cloud infrastructure. So that's Elastic and Kibana. But then we also need to set up a reminder to let the citizen know once a day that it's time to resubmit their symptoms. And the way that we do that is we send an SMS out 24 hours after initial submission and 24 hours thereafter. And it includes a one-time use unique URL that means that the patient can just tap that link and they're taken straight back to the form. And what's interesting there is that the patient then doesn't need to, I say patient, we work with patients so much, it's citizen in this case, not necessarily a patient. But the citizen doesn't need to tell us who they are again, because they use this unique one-time use URL, and that includes a unique token that is meaningless outside on the internet. It doesn't contain any identifying data, it's just a random string of text. But what that means is that when the user submits the form for subsequent submissions, we can then take that unique token and we can reattach their identity to that data. So this is a pattern that we've developed within our product set, and it solves a challenge of requesting someone to fill out a form, but without wanting to have to make them register a user account, or without wanting to have to ask them to provide personally identifying data. So as long as we have enough to, within our tokenization service, which is where we store all this data, as long as we have enough information about them to reattach that data to their patient record later, all we need to do is generate that one-time use token and send that to them. So there's a few other bits and pieces in here, which is incidental kind of technical detail of our overall infrastructure. We use MongoDB, for example, to store configuration from our integration engine. And we also have things like job runners that run background tasks, and we use Redis to store the states from our tokenization service. And we also use MessageBird, which is again, a public service that's available for sending SMS. This is not a free service, it's a paid service that we use to send messages to the citizens. Okay, so I'm going to jump out of presentation and do a few demos here so that we can kind of see how this comes together. So first of all, very quickly, this is the website. This is COVID symptoms, COVID-19 symptoms.co.uk. And for anyone who hasn't seen this, the way that it works is you are taken through a very easy to use form. You're made to understand that the form doesn't provide any medical advice. You're asked whether you've shown any recent symptoms, whether you've been in contact with anyone who's shown symptoms. You're asked to describe your current state of health. And then you're asked more specific details about the symptoms that you're experiencing, if any. So for example, if I said that I was experiencing a cough and a high temperature, I'm then asked to provide a bit more detail about those symptoms. So, for example, if I've got a high temperature, I can enter a specific temperature reading if I happen to know it. If I don't, I can just leave it blank, and it's enough detail for us to do analytics on to know that they believe they have a high temperature. And then using these kind of user-friendly slider controls, we can kind of dial in how persistent our cough is, and how well we feel generally. And of course, under the hood, this is structured data, so we generate a number from the slider, a number between 0 and 10. And from there, we ask for a postcode. We do need that. We're not using it for any reason other than to be able to get geographical data against these symptoms. It's very important for us to know how the symptoms are spreading across the country and where people are when they're reporting these symptoms. So if I provide a postcode, and then we're asked whether we want to link our response to the hospital record. So as Julie said, one of the kind of unique points of this is that we're making it very easy to integrate into downstream systems. And if we are happy enough to do that, we can either provide an NHS number if we know that. We recognize that most people don't know their NHS numbers. So if you don't, we ask for a few key bits of information about the person. And from that, we can then reattach that to that patient's record, and we can triangulate their NHS number from those details later. So jumping into some of the tools that we've used then, I'll start with the UI. So we use Forms for Health, which is our low-code forms platform, e-forms platform aimed at healthcare. So the way this works is we have a management environment, which looks like this. And from here, we can create forms using a kind of what you see is what you get builder. So what we do is we create building blocks. A building block is a reusable component within a form. And a form can contain as many or as few building blocks as you see fit. So for example, if I was to create a building block, we're taken into our building block designer. And this is where we start to put together what this form should look like. So in fact, I'm going to use our demo environment, which if you do want to follow up on any of this and have a look at this in more detail yourself, demo.formsforhealth.com is our kind of publicly accessible environment. So as you can see, we're asked for some information about the building block. And then from that point, pretty much all we do is start dragging or start placing controls onto a building block designer. So as you can see, this is all very low code. I could have a first name field, for example, and then I can add another row underneath and a number, and maybe that's age, and then I can add yet another row underneath and maybe do a date, and maybe that's date of birth. And we can then put validation on any of these fields. We can do cross control logic. We can do conditional logic, conditional visibility of controls based on other controls and so on. But maybe something kind of simple. If it's a date of birth, it makes sense that I shouldn't be able to provide a date of birth that's in the future. So what I can do is I can go into validations and alerts, and I can just specify that it must be before today or today, for example. Now, if it was something a bit more complicated, so for example, maybe the age should only show if the date of birth is filled in, or maybe it should be a calculated age based on the date of birth. What I can do is I can go into the formulas section here, and Forms for Health is much like something like Excel, for example. So Excel can go from very, very simple for a simple table of kind of static numerical values, all the way through to very complicated if it's doing lots of formulas and lookups and pivot tables and all sorts of things. So Forms for Health is similar in a sense that for a very simple form, where there's very little validation and very little logic, it's really just a kind of drag and drop exercise. But if we need to do more kind of conditional logic, we can use XPath to query the underlying structure of the form and produce an expression that evaluates to something sensible. So for example, if we were trying to use an XPath to determine whether the control is visible or not, we can use a Boolean XPath expression. So I could refer to another control and I could say date of birth is equal to something, and that will then result in a Boolean evaluation that determines whether or not that control is going to be visible. So from that point on then, once we have a building block, we can then start to create a form. And as I said, a form is a collection of building blocks that come together. So again, using our design environment, I give the form a name. And a form can behave in one of two ways. It can either be a clinician-facing form, which has a slightly different look and feel and some different characteristics, or a single pass form, which is something that typically a patient would fill out. And from that point, I pretty much just start to set up the form. So I give a page title, and I can then insert a building block. And as simple as that, I can then start to view that, and you can see now we have a form that is already available on the internet and already ready to start collecting data. So those of you maybe a bit more technically inclined can probably see that very quickly we can produce a UI, but underneath the hood you still need some kind of logic, some kind of processing of data, some downstream behavior. So out of the box, what Forms for Health will do without any configuration is it will create a PDF and it will send that PDF to a specified email address. And this is really good as a kind of low barrier to entry approach for setting up a form and collecting data from it very quickly. So for example, some of our GP practice customers use it in this capacity. They'll have, for example, e-consultation forms on their website that allow their patients to go in and book an appointment or something like that. And because they don't have complex IT systems behind all of that, they're just a small GP practice, it's enough for them to just receive a PDF in an email that's sent to a receptionist or a back office worker, and they will then go about and schedule that appointment or do whatever needs to be done. But of course, Forms for Health is a full framework of tooling that can be used all the way through from very simple to very complex use case. And probably at the more complex end, it's fully integrated into Leeds Teaching Hospital's electronic patient record. And it is the primary data capture tool that is used within their patient record. To do that, they've used plugins. So all our product exposes various different plugin points that allows you to use your own persistence, do your own downstream processing, or use the data in other formats than a PDF, for example. So going back to COVID-19 and this scenario, we've plugged Forms for Health into our integration engine to allow us to do all the things that we need to do to store the data and to triangulate latitudes and longitudes and all these kinds of things. So I'm going to jump into our integration engine to give you a kind of sense of how that comes together then. So an integration engine, for those who don't work in healthcare, is not something that we've devised. It is a kind of healthcare recognized concept. It's a decoupling mechanism, if you like. It's something that sits between two disparate systems that talk to one another, but don't necessarily know anything about one another's interfaces. So typically speaking, you can either do what we refer to as a point-to-point integration, where two systems directly communicate, and you would then have to have the code bases of those respective products having some knowledge of what those interfaces look like. Or you could pass that through an integration engine, and the engine itself abstracts all of that integration logic and handles it for you. So our tool is, our product is what we would refer to as a lightweight integration engine. It handles more modern use cases like integration over HTTP and integration using more modern protocols. And it's less geared up for kind of legacy mainframe protocols and very low level protocols that we do see in some older systems. So the way that it works is you create an endpoint. And an endpoint is something that's callable over HTTP, or HTTPS, I should say. And an endpoint is something that you dynamically build up within the tool here. So I can provide a name for an endpoint, and I can then line up some tasks for the endpoint to run. And that could be something simple, like making a HTTP request. Or something more healthcare specific, like sending some data over the mesh delivery mechanism. Or it could be something like sending an email or sending an SMS or running some kind of background job. We even have to handle scenarios where fax, inbound fax and outbound fax is happening. So the tool does allow us to do that as well. So let's do something really simple. Let's just make a HTTP request. And from that point on, then what we do is we have to prepare this endpoint for what type of data it should expect to receive. And we support a number of formats, some of which are more kind of instantly recognizable than others. So everyone has come across JSON, no doubt, and XML, and of course query strings. But people who don't work within healthcare are probably less familiar with things like HL7v2 or HL7 Fire. And so on. But the idea is that you have to teach the endpoint what shape of data to expect. And under the hood, we generate a schema. So either a JSON schema or an XSD XML schema. And that means that when this endpoint is invoked, we can validate that the data we're receiving is of the shape that we expect, so that we don't have runtime errors that fall over downstream. Okay, and from that point on, then what we do is we start setting up this task that we've queued up for the endpoint to run. So if you remember, we asked it to make a HTTP request. And of course, a HTTP request comes with certain bits of information that you need to provide. Of course, you need to provide a URL, some kind of HTTP verb or method, maybe some headers to include, maybe some certificates, if there's some kind of certificate chain. And probably some data, some body of data. And the key thing here is to recognize that all of this can be either done statically or dynamically. So for example, I could type in a static URL, and this endpoint, whenever invoked, will always call google.com in this case. Or I can dynamically pass some of the data from my inbound data into the URL. So in this case, I will take the name property from the JSON that I receive, and I will use that as a URL. The same goes with the data that I create. So for example, if I had an age property, maybe that's hard-coded for some unusual reason, and then I can dynamically pass through a name, which I could take from the body that I receive. Same goes with headers and certificates and so on. All that can be either dynamic or static. And from that point on then, I pretty much just save and deploy, and that endpoint will then be available on this URL to be called, and will do all the things that we ask it to do. So going back to COVID-19 and taking it from a very simple use case to something that's a little bit more complicated, when our COVID-19 symptoms collector form is completed, this endpoint here is invoked, and this does a number of things. So first thing it's going to do is it's going to call postcodes.io to get the location of the citizen. It's then going to map the data into the format that we need. And then we're going to then make a request. So we're going to push that data into our Elastic data store. And I don't know if you remember, I mentioned that we use a kind of tokenized delivery method to send a unique one-time use URL to the citizen. So in order to do that, we call our one of our other services called AirToken to request a token and to persist a few key bits of information about the citizen, so that after 24 hours, when the citizen resubmits, we can then retrieve their information from our Redis cache, and we can reattach that token to those key bits of information. And the last thing that we do is we set up a reminder job to send an SMS to that citizen asking them to recomplete. So you can see here, this is the kind of initial setup. First of all, we set up some authentication. We're locking it down to a certain IP address, and then we're queuing up the tasks that we need to run. And as we did before, we set up some input data. So this is preparing the endpoint for the data that Forms for Health will send us in its native XML format. From that point on, we need to call postcode.io. So you can see we're making a partially static and partially dynamic URL here. We're passing in the postcode from our inbound data into that request. We use response handlers. This is the way that we anticipate a response, and we can validate a response contains the data that we require. So what that means is that when postcodes.io responds, as long as it includes this data within its body, within this particular schema or conformant to the schema, we can then go ahead and carry on processing. What we don't want to do is receive something that's actually quite different and carry on running and maybe fail downstream when we've already done a number of these other tasks. We want to pick that error up as early as we can before we've actually done other things with it. So this is our mapping. We use a mapping task to do all of the heavy lifting, transforming data from one format into another. And it means that any data that we create in a mapping task can then be retrieved in any subsequent downstream tasks. So this is JSON, but it's JSON with our kind of native templating syntax within it. So we use, it's not actually a proprietary syntax, this is liquid syntax, which may be familiar to some. It looks like some of the syntax that you might use in Python libraries and so on. But yeah, it means that we can do conditional things like if this data is something, then we include these properties, or else if this is the case, then we can include these other properties and so on. Now what you might see is a bit of a mixture of syntax. This kind of double curly braces syntax is native liquid syntax, but this -- star syntax is our proprietary path syntax. So the way that this works is under the hood, any of these paths are, or any of these properties I should say, are linked to a path. And that could be an XPath expression, such as this, or it could be a JSON path expression if we're querying some JSON. So then once we've done our mapping, when we're doing initial debugging and setup, we often use a tool called a request inspector. It's not a product of ours, it's nothing that we've built, it's a for free available on the internet way of inspecting HTTP requests as they come in. Now what we often do is we just filter that out when that comes into production. So you can see we can include a Boolean XPath expression here. So true clearly does not equal false, therefore this task won't be run anymore. And then we're going to push the data into our Elastic backend data store. So we have a Elastic Cloud instance that we store all of our data in. And we map in the JSON from our mapping task. And we include some headers with authentication in and things like that. Our next task here within the pipeline is to call our AirToken service. So we're going to provide as much information about the citizen as we need to be able to retrieve their identity later on. So we're going to create a subject ID, which is a consistent GUID that runs all the way through any subsequent submissions that they make. We're going to store their postcode, phone number, and so on. And all that means is that we can retrieve those later on when we need to use them. We then anticipate a response in a response handler, and that means that we can retrieve the token to use it. And from that, we then set up a job. So a job is a headless background process that runs on a predefined schedule. And you can see some of this kind of slightly scary looking syntax is dynamic cron expressions. So we grab the current minute within the current hour and the current hour, and we build up a cron expression which is dynamically created. And it means that we can then run this SMS reminder exactly 24 hours after the initial submission. From that point on, we just go ahead and save. And we have a similar pipeline for a follow-up form, which is slightly different. So as I said, 24 hours later, the citizen resubmits, and they will then fill out a slightly different form, which doesn't ask them who they are and what their postcode is and so on. And they then will pass that data to this endpoint, which does some similar things, but some of them are slightly different. And all of these requests will then go into our kind of usage data dashboarding, where we store all of the kind of metadata about these requests as they're made. What we don't do is we don't store any patient data, we don't store any citizen data or any transactional data. We only store high-level metadata about these events as they occur. So we can go all the way through a transaction, all the way through a request, and see exactly what happened in a kind of a nice sequence diagram layout. So the other piece to the puzzle that I mentioned, we do use Kibana and we use Elastic, and it means that we can then use all of this data analytics tooling, these dashboards, and there's machine learning functionality built directly into Kibana, and we can produce all this analytics visualizations of the data that we're receiving. So you can see we're seeing, for example, high levels of coughs, high levels of headaches, for example. Maybe more interesting, some symptoms within confirmed cases. We're seeing a lot of headaches and sinus congestion, loss of taste, loss of smell. Not seeing much in the way of coughing, for example, which maybe you would expect within confirmed cases. So I think that's probably a good kind of summary of the tools, how they come together. Daniel, did you have anything to add to that?
Yeah, I guess we do have some slightly different use cases as well in some of our other situations. So what we've been looking at here is a system that's exposed to the general public, and so some of the work that we're going to be doing for Greater Manchester is going to be using this form, but targeted more specifically to NHS staff. So in that scenario, we're going to be sending them, say, an email or a text message or something like that, which is also going to be using our Airglue facilities. And and in actual fact, as part of doing that work, the fact that we've been able to move very quickly has really been the thing that's allowed us to first of all to get the work, and then also to be quite successful at it, because the situation sort of has required things to be quite fluid, and for shall we say, committee decisions to happen and the thing to go live later that day, and so on. And so yeah, our rapid tooling's been very useful for that. Yeah, there we go.
Right, brilliant. Is that it, guys? That's been really, really useful.
That's it for me.
That's fantastic. Really interesting about the symptoms at the end. I thought that was really the headache. I think I did lose my sense of smell and taste a few weeks ago. So yeah, there we go. And that fax is still used as well. I'm amazed by that. Just want to open it up now to everybody else that's on the webinar to see if there's any questions. If anyone's got anything specific, either put it in the chat or you can mute yourself. Is any at all?
Oh yeah, can you hear me?
Yes. Hello.
Yeah. There's another major equivalent of this, the King's College one, is it? Let me just have a look. Is there any stuff going on to pull the data from both services?
David,
Yeah,
sorry, Julie.
Yeah. So behind the scenes, so our chief exec, Mike and Joe, along with some of the Leeds clinicians, have been working with the Swansea group, who are actually working behind the scenes with St Thomas's. So yeah, we'll definitely be collaboratively working with them. We obviously have to put in data privacy agreements. So our legal team has been liaising with their legal team.
Good.
Yeah,
Good.
so definitely working in collaboration with them.
Excellent.
Anybody else? Any more questions?
I did have one question, if that's okay.
Yeah, go for it, Andrew.
Yes, so would this tool, maybe in a year's time when the COVID's been brought under control, be used as more of a general health of the nation application where you could spot outbreaks coming with people updating this app rather than relying on them going to a GP service and going surgery, going I'm ill, and then picking up outbreaks that way? This could be more of a faster response. Yeah, that's pretty much it.
I'll just jump in there briefly. So although it's very early days to say, one thing that's come up in quite a few discussions is that there's a lot of new healthcare systems are suddenly coming about through necessity and through need. And so a lot of what's happening now is driving change. And so we are, I think it's almost inevitable that we're going to see a lot more sort of home diagnosis type systems and so on. And a lot of the things that we're developing now, part of which this is one, will certainly be used a lot more in the future. I think, especially even after this situation has passed, I think it's extremely unlikely that we're going to immediately just snap back to how we were before. I think the push towards sort of more distributed and at the same time personal health care is definitely coming. Does that answer your question?
Yeah, that was pretty much it. Like where it could be used after COVID, and it sounds like things are already in motion. So yeah, thanks.
Yeah, I think it's also worth saying that this kind of model that we've put together, you can use in all sorts of different situations. We do have another one, for example, that we're just under development. That's a mental health and well-being tool. Of course, it's all got to be used in conjunction with the use case. So, if there's a need, then we're willing to work with people. So. Yeah, I think it's the beginning of a new era, if you like, for using tools like this within the health area.
Brilliant, thanks for that, Julie. Any other questions from anybody else?
Oh, hi there. Yeah, it's Vic Sharma here.
Hi,
firstly, hi guys. Thank you very much for a great presentation. Just a general question in terms of in terms of your process and how you went about doing these things. Any issues or pitfalls? I'm sure there were plenty. I mean, anything you can share with us in terms of experience, like any watchers or gotchas in terms of training the engine, the machine learning engine versus, coming with the use cases and then the personas, the access control part, and then doing the functional design. Anything you can share with us at this stage?
I think one of the things that we realized quite quickly is getting the data up front is more important than kind of scrutinizing up front on what the machine learning algorithms should be and what the analytics output should be, because that's something that we can do retrospectively. Having the data when we have the public's attention and when people's awareness of the COVID-19 crisis is at its peak, is the most important thing to begin with.
Okay, all right. And how many iterations of design did you go through to get to the final product? I guess it's still in development, right? There's or evolving.
Sure, yeah. So we launched on V11 and we're now on V13. We went through kind of 10 or 11 versions before we went live.
Well, practically one every day then, right? A revision.
Pretty much, yes.
Yeah. Okay. All right, thank you.
Thanks, Nick.
We work in a really agile way anyway. And basically, because we were all working from home, that was also quite a challenge. Normally we would have stand-ups where we could
Right,
like talk to each other. So we had like an open chat channel, and often on the chat channel you'd have 3 or 4 different conversations going on at once.
Being
So
there,
with the designer, the tester, the business analyst, the developers, it was actually quite interesting to see it all come together.
right. Thank you.
That's all your questions, Vic.
Oh yeah, thank you. Thanks for that. It does.
Okay, anyone else this time?
Hi, it's Donnie here. I've got one
All right.
Hi. Great presentation, really useful and knowledge sharing. Great. Now through this journey, is there anything you've done differently?
Anything that you'd do differently? I think that was right. Was that right?
Yes.
Yeah.
If we could have launched it 2 or 3 weeks earlier. I think time, wasn't it? Time was an essence, and nobody could. I think that's what I was trying to say at the beginning. Nobody knew what was going to happen, and we were, you're riding against also what's happening in the media and the fast pace of how it's all moving. So, and obviously that was completely out of our control.
Yeah, I think if we'd have built it before the pandemic even began, then we could have really been on top of things and kind of rode the initial wave of enthusiasm. But of course, we can't predict the future, sadly.
Question from me, David. What's been the uptake of the use of it from citizens? Is it in the thousands of people?
No, we're still in the hundreds per day.
Right.
We are seeing it kind of growing, and we're hoping it will continue to do so. I think we're trying to push it from lots of different angles, but we're still in the hundreds a day.
And of course, there's changes that are going on. We're now seeing a shift. We're looking at, the elderly and the more vulnerable. They're obviously now very much in the news. Also looking at staff using it. Nobody knows when the end is in sight. And of course, because of all of the complications around testing, I think the government are looking at, well, what can they use? How can we manage this? So there'll probably be other use cases that come out of it.
Anybody else for any questions at all? No? Right, okay. Well, yeah, I think that takes us close to the hour. So I just want to say a massive thank you from me to David, Julie and Daniel for giving up the time. It's been absolutely brilliant. It's been really, really insightful. I don't want to take up any more of your time. So it looks like you're doing some really important work. So yeah, just big round of applause from me and from everybody else. So yeah, thank you very much.
Thanks, guys.
That concludes the meeting. So yeah, thanks a lot. Cheers, everyone.
Oh, thank you. Bye.
Thank you very much. Thanks, guys.
Hey, guys.
Bye.
Are you there, Chloe?
I guess we just go then, do we, Rob?
Yeah, I just want to say a personal thanks to you guys when everybody else had left. I think there's a few people. It's fine. But yeah, thanks a lot. Really appreciate it. Thanks for giving us your time there. We'll make sure it goes out on YouTube as well.
Yeah.
So if you want to promote it that way.
Yeah.
Yeah, but looks like a great
I think
song.
what I'm just kicking myself a little bit at the end there, because we are using it with Manchester staff, and actually it's going to be big. It's going to be big.
Really?
So yeah.
I wasn't quite sure if I should jump in at that point or not. So so we know we're targeted for about 75,000 staff to be well, they're going to be targeted with this starting hopefully next week, to be honest.
Right. So just in the Manchester area.
That's right. Yeah.
Right. Okay.
Although it's looking very likely there's people watching that one as well, so it will move into Cheshire almost, the week afterwards, if you like, and so on. So this
right. That's brilliant. So are the government going to get in touch with you then to throw it out everywhere, do you think, or is that how it works?
Well, it's a weird thing, isn't it? Because like we've had Leeds clinicians endorse it, but there's quite a bit of politics as well behind the scenes,
Really?
that you don't necessarily realize. So although like the Leeds Trust have also they've privately endorsed it, they can't publicly endorse it. Do you see what I mean? So so we're it's very much like, right, okay, we've got this tool, if you want to use it, then do use it.
Is it on a clinician level? Can they just make that decision, and it's per individual almost if they take it up? Is that right?
I think there's somebody who's just joined us. Is there somebody who's just?
I don't know. There's 10 people here. They're having a bit extra.
Oh, I see. I didn't even realise there was. Okay.
I haven't ended it with everyone. I don't know how to end it with everybody. This is extra bits, bonus.
Yeah, these behind the scenes. Yeah, I don't know, to be honest.
It's really interesting.
We have the tool, and basically things are unfolding, aren't they? So we have now the more vulnerable, the older people, and potentially this form, it's really so easy that the older generations can use it. I think at the moment a lot of places don't have headspace for anything other than firefighting. So I don't know what you think about that, Daniel. We've got there's I know there's things going on in Manchester as well, isn't there?
Yeah, so it's an interesting time, shall we say, in that it's the same. There's a lot of sort of conversations along the same lines. There's a lot of things where people just don't have headspace to think about it right now, so it's just been cancelled. But then again, there's a lot of other work whereby it's things that had been scheduled to take 18 months, and it's like, right, well, we need that next week, just do it.
Yeah. There's a lot of that going on, I'm seeing. Across companies. That 3-month project, it's 3 weeks, so get it done.
I suppose from our point of view, we've got all the legal side done. So we've got the privacy, there's a lot of discussions around, privacy agreements